Hey guys, here is your next video. This is called Bohr's Model, and the top of your paper is called Bohr and electron dot diagrams. There's two different models we're going to talk about, and the first one's Bohr's Model, and I broke these into two videos in 2 days worth of work, so we'll do the first one all together, and the second one you'll be able to do more on your own. So for Bohr's model, the definition, or what its purpose is to show all protons, neutrons, and electrons that an atom has. And so I want you to underline that or write it down. If you're just taking notes, let's talk about this paper. So you could print this paper, that's totally fine. And then once you fill it out, you'll take a picture and upload it. It's on a Word document, so you can fill it in as you go if that's what you want to do, and then save it and upload it. That's what I would prefer, is for you to type right onto it and save it and upload it. Or if the formatting is crazy, then you could just number these things and write the blank words, the words that you would be writing in where the blanks are on a Word document and save it, or type it in the text box. Whichever is easiest for you is what I want you to do. Okay, so underline that or write it if you're writing on paper. Bohr's model shows all of the stuff inside that atom. It shows us the protons, it shows us the neutrons, and it shows us the electrons. That tells us, it shows us everything. So that's what you're going to do. When we complete a Bohr's model, the first thing we do is we put the protons and the neutrons in the center. And I'm going to show you an example in a second. So you would write P and N and a little equal sign, and then you would draw a circle around them. Oh, and then the number sign, not the number sign. You would write what the number actually is, and then draw a circle around them. So that's the first part you would do. Draw this right there to that right where this is on this paper. Draw that in there. Or if you're using a Word document, you can insert shapes and do it that way. So then you have each circle then is going to be an energy level. And so the first energy level can only hold 2 electrons. That is its rule. And over there on the left you see energy level 1 is called the K level, and it can only hold 2. It's talking about 2 electrons. Then you see that I already drew the second energy level, and it can hold 8 electrons. And if you look back to the left, energy level 2 is called L and can only hold 8. Again, that's the rule. And then we have the third energy level, which is called the M energy level, and it can hold 18, but we only draw 8 on there. And these two models we're about to talk about today have been around for a long time, and like Bohr's model is like the early 1900s, and it's flat, and it's not as accurate as the today's model is, which is an electron cloud model, which is the one you see with like the electrons moving around in a circle that when they're in 3D. It's the one from like the Big Bang Theory where it shows the atom. That's an electron cloud model, and that's the appropriate, most accurate model. But we still use these two models for simple tasks in chemistry. Anyways, there's a fourth level, and it can hold 32, but we won't ever go above level M because things change and get more complicated. You'll talk about that in high school. All right, so the next thing you need to know is that when you put the electrons on the model, you are putting them on a clockwise motion, starting at 12 o'clock, where that first black dot is. Then you would go to 3 o'clock, then 6 o'clock, then 9 o'clock, if you were on a level that held 8. So they go clockwise. Make sure you make a notation on that. All right, so now we're going to use the skills that we got last or 2 weeks ago using the periodic table. And you have to remember that, the atomic number tells us how many protons there are. And however many protons there are, there's that many electrons. So you have to pull back on some of the stuff we have covered. Plus, it's over here for you written down to help you. All right, so I just screenshot the little corner of the periodic table that we're going to be talking about for us to reference, so you don't have to go find one. You can get yours out if it's clearer to see, because I know the purple column here on the gases is a little difficult. So we're going to talk about fluorine. So first we need to find fluorine. Oh, I wrote you the reminder. Atomic number equals the number of protons. And so fluorine is right here, and the atomic number, which is this number right there, tells us how many protons there are. So there's 9. Then we need to find the neutrons. Well, to find the neutrons, you need to take the atomic mass, which is this number, and I'm going to fast forward for a second. So the atomic mass. So you can see the atomic mass is 18.998. We will round up for simplicity's sake when rounding up is appropriate, or we will leave it as it is when it is appropriate. So 19 minus 9 equals 10. And I'm using that number, that formula, because of right here. The mass, the atomic mass, and you subtract the atomic number from it. And so that gave us 10. Then electrons. Remember, electrons equal protons. So however many protons you have is how many electrons you have. And you get the proton number from the atomic number. So there's 9 there. Then we're going to talk about energy levels. But before we can talk about energy levels, how many electrons are in each energy level, we have to start filling in the diagram. So P equals, and go back up to the list, for protons we have 9. N equals, going back up to the list, we have 10. And then we're going to plot them on this diagram. So we start at 12 o'clock. Oh, so there's an exception to the rule. On level 1, where there is only 2 electrons, we do them at 12 o'clock and at 6 o'clock. Everything else we go clockwise. So the first one is at 12 o'clock, and then the second one goes down there. So that's 2. So in the first energy level, we have 2. Then we're going to continue counting and filling in the energy level. The next energy level, the second energy level can have 8. So we're going to see if we fill that up. So starting at 12 o'clock. So we already have 2, so we're going to start with 3, 4, 5, 6, 7, 8, 9. So now we've gotten 9 electrons. We have put all of them on there because this is the number we're putting on, 9. And then, so for the second energy level, 2 from 9 equals 7. Or you can just count them. 1, 2, 3, 4, 5, 6, 7. That one didn't go. Okay, got it? Moving on to boron. So boron is up there on the left. It's in that green box. The proton amount is the atomic number. So the atomic number is 5. Then we're going to take the atomic mass, find that. Atomic mass was 11. Oh, there's another example. It was 10.8. We're going to round up to 11. And then you take the atomic number and subtract that from 11. And so that gave us 6. And then we take the atomic number for the electron, so it's 5. Now we're going to fill in the diagram. P equals, going back up to protons, 5. N equals, going back up to neutrons, 6. Now we got to put our dots on. And I started having tons of problems with my pen putting these dots on earlier, and so you'll have to bear with me as I fight with this program. So the first energy level, we know it can only have 2 because that's the maximum number it can have. So I went ahead and put that number in first, and then I drew them on. Remember, 12 and 6. And then we're going to count to 5, starting at 2, because we already have 2 electrons on. And we have 3, 4, 5. And so 2 from 5 equals 3, and that's how many are on the second. All right, I'm going to keep going. The bottom left, number 2, is neon. And so here I've circled neon for you, and I know this one is hard to see because it's in that purple. But we know that the atomic numbers increase as they go across the period. So fluorine is atomic number 9, so then we know that neon's atomic number is 10. Then taking the atomic mass, it is 20. 20 minus 10 gives us 10. If there's 10 protons, there's 10 electrons. How many electrons go in the first energy level? That number is always the same unless it's hydrogen. Oh, I forgot to put the P in there. So protons inside is 10, neutrons inside is 10. And now we're putting on our 2 electrons. Now we're going to continue from 2 to get to 10. 3, 4, 5, 6, 7, 8, 9, 10. 2 from 10 is 8. That's how many are on that level. We also know it's 8 because that is the most that energy level can hold, and that's 2, 4, 6, 8 all the way around. All right, moving on to argon, which is right below neon. It's also a gas. Again, it's hard to see its atomic number because it's in the purple, but if you look at chlorine, chlorine is 17, so argon is 18. Okay, then we're going to find the atomic mass. Atomic mass, I believe we rounded up to 40. We're subtracting 18 from it, and that's going to give us 22. The atomic number the number of protons was 18, so our number of electrons is 18. The first, put the P inside, that's going to give us 18. Put our N in there, that's 22. And then our first energy level is going to have 2. Sorry, I had lots of problems with these dots. All right, so there's your first 2. Then you're going to enter the second energy level, starting counting with 3, 4, 5, 6, 7, 8, 9, 10. And then we have to go to the third energy level because the second energy level is full. 11, 12, 13, 14, 15, 16, 17, 18. All right, so when we looked at the top of the paper, it says the first energy level, level K, can only hold 2. We got that. The second energy level, called level L, can only hold 8. Got it. And then the third energy level, level M, can hold 18, but we only draw 8. We won't draw any Bohr model above argon because it gets more complex going from there up. That is a high school thing you'll do. So if our total number of electrons is 18 and we have 2 on the first energy level and 8 on the second energy level, that's 8. That means that we have 8 on the third energy level. All right, a couple more notes and then we'll be done this video. So exceptions. There's always exceptions to the rules. You know that, just the way it is. Helium only has 2 valence electrons ever, and hydrogen only has 1. And so when we were talking about, not hydrogen, but when we're talking about helium, the fact that it only has 2 valence electrons really, it makes it not fit in its family or its group, which is the column that goes up and down, because when you look at those, everything in that gas column should have 8 valence electrons, except for helium. It only has 2, so that's an exception. When we are talking about the groups to find valence electrons, we never look at transition metals, okay? We don't plot those on Bohr's models, and we don't count those in the group numbers when we're counting valence electrons. So it does not apply to those. And then when we are looking at the groups or the families, you know that they're numbered across the top from 1 to 18. Well, we don't count 3 through 12. So when we get to 13, we have 13 through 18. But there's not 13 valence electrons on a level. But if you subtract 10, it gives you the right number. So what I mean by that is, let's see if I put a picture in here. I think I do it with these in an example. We'll do an example of that in a second. So we're going to define valence electrons. Valence electrons are electrons on the outermost energy level. It determines which atoms bond, which is very important, but that's a later in chemistry thing, probably high school. All right, so here's a picture of our corner of the periodic table. Oh, there's a typo also. That should be just F, not FL, for fluorine. And, all right, so the very last column, the gas column, that's column 18, and then 17, 16, 15, 14, 13. I don't know why I went in reverse, but there you have it, 13 through 18. And so we're going to subtract 10 to give us the valence electron numbers. So if we subtract for fluorine, if we subtract 10 from 17, it gives us 7. That's how many valence electrons are on that group or that column. So anything fluorine, chlorine, bromine, those all have the same number of valence electrons, which is the last energy level that atom has 7 electrons. Now we're going to look at boron. So boron is 13. 13 minus 10 is 3. So there's 3 valence electrons on the outermost energy level of boron. So when you're plotting these on a Bohr diagram or a Bohr model, you can check yourself to see if you're right by looking at the valence electron number and see if that's how many you have on your outermost ring. It will also help you when we get to the electron dot diagram, because that's what we plot for that. All right, neon. Neon has 18 minus 10 gives us 8. So neon has 8 valence electrons. And then we're doing argon. Again, that's in the 18th column. 18 minus 10 is 8. I did it up here in the right-hand corner. And then, so neon and argon are the same valence electron number, guys, because they're in the same family. They're in the same group. They have similar properties, like we talked about. Families have similar characteristics. I have blonde hair. My son has blonde hair because we're in the same family group. Same thing with these numbers. They have the same valence electron numbers because they're in the same family group. All right, that was a lot for not very many questions. If you have questions, email your teachers.